Good afternoon, dear Dr. Kamisa. We are from Group 8. We would like to present our program-based learning presentation today, Stability of Structure. These are our group members. That's Muhamad, Aqil. This is Benedict. This is Parasuraman. This is Raja, and that's Fadli. This is the fila that we have obtained. Our facts that we have obtained today is the structure is constructed using elastic bars. The elastic bars obeys the Hooke's law. Rivets and bolts prevent rotation. Rotational motion induces stresses. Equilibrium requires all forces to cancel each other. And finally, the structure will collapse under extreme stress. Next is the ideas that we have obtained. Larger surface area of the structure to maintain stability. The branch elastic bar rod must have high elasticity to withstand internal force, and it also needs to be stable to avoid collapsing as it is swing. And the structure must also be stable enough to withstand rotational force of the swing. Besides that, the connection of the angle must have a certain angle to increase stability of the structure. The learning issues that we have obtained are: what are the material used for the rod to withstand high external and internal forces? What are the angle of connection required which will increase the stability of the structure? What are the material used and how to withstand rotational force? What are the maximum external forces that the structure can hold without collapsing? How to know that the structure achieves equilibrium? And finally, how to know the value of internal force of each branch of the structure? Our action plan. The lecturer and tutor will be our guidance to solve the tasks that are given to us. Discussion between colleagues will be resourceful to generate ideas for overcoming problems. The library will definitely be a good source for books to search for knowledge that are related to our program. And finally, the internet contains a lot of knowledge to tackle our problem. So this is our discussion. Our main question is how to determine the stability of a structure using an incidence matrix technique. For example, we'll take this structure as an example. This structure has 3 branches, 4 nodes, node A, node B, node C, and node D. We have to create a matrix based on the structure. What do we have to do for that? We have to calculate position vector for node A, node B, node C, and node D. We calculate the position vector for every node for vertical component and the horizontal component. After we've calculated the position vector of node A, we minus it to find the position vector of node B. And we do the same thing for node C and node D. So we'll obtain 2 components for every node. So they have 8 values, 8 position vector. And based on these vectors, we'll create a matrix. And that matrix is in AT form. We have to transpose this AT matrix to get matrix A. And this is the formula used, matrix AT. The formula given is ATX equals to F. X is the internal forces, F is the external forces, and A is the incidence metric. In order to find A, we have to transpose the AT matrix to find the incidence matrix. And after we find that, you have another formula, KU equals to F. K is the value we have to calculate. And you can obtain K by multiplying AT transpose with the C matrix and A. A is a diagonal matrix which represents the bar stiffness. Since it's a diagonal matrix, you will replace the diagonal with 1, so it's an identity matrix. So if any matrix multiply with diagonal matrix, we get back the same thing. So A transpose multiply with A matrix will get the K value. Okay, after we've obtained incidence matrix, the next step we have to know is how to know if the structure is stable or not. After we've obtained the incidence matrix A, we have to reduce the matrix in order to know if the structure is stable or not. And if a trivial solution is obtained, then the structure is stable. But on the other hand, if the incidence matrix has no trivial solution, then the following steps must be taken. Firstly, we have to ground the nodes, or we can add additional branches. As you can see the structure, it has 4 nodes. So if the matrix, if reduced to echelon form, if it's not in reduced to echelon form, we can ground node A and node D. And after grounding it, and if we reduce it, if still don't get trivial solution, then we add another branch from node B to node D. And after this, we have to cancel out the ground A and node A and node D. And after we reduce it, if the answer obtained is in trivial solution, then the structure is stable. Okay, that's all. Thank you.
Assalamualaikum warahmatullahi wabarakatuh, and good evening. Well, just now Shaarmini has just said the importance of incidence matrix of a structure to provide its stability, to show its stability and the position vector. Well, now I'm going to show a little bit detail about how you find the matrix A transpose and transpose it into matrix A. Well, let's take a look on the image, shall we? Well, this is node A and node B, node C and node D. Well, you have three branches there, branch A, branch B and branch C. So now we have this formula, xy minus x prime minus y prime over the unit vector of that particular vector. Well, for branch A, now we have vector position 0, 0 and for node is 1, 1. So by using those position vector, we can now calculate the horizontal and the vertical. So 0 minus 0, 0 minus 1 over 2. So we have horizontal for node A and node B, and the same goes for branch B. As you can see there, you can calculate based on this node B and node C and D by using the same formula actually. So after this, we can use the data we have find on each of the branch, so we can create matrix A transpose. As you can see there, there are x1, x2 and x3. So you can see there are x1, x2 and x3. So from there you can figure out how to create matrix A transpose. So after we find matrix A transpose, we need to transpose it back to its original. So this is matrix A. So as you can see there, this column will be this row and the second column will be the second row. So it's just simple as that. So what does Shaarmini mean about grounding and add another branches? So let's take a look at grounding. So if you got a case with grounding a certain node, such as node A, so for example we ground this. So that means the matrix A, we have to cancel out the whole node A. That is meant by grounding. So for example, if you want to ground node D, so we just cancel node D. So that's just about it. So for example, if you want to add another branch, for example from B to D, so we just add another row, another new row. For example, like blah 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 blah. And so this is the new branch, which is D. So it is quite simple actually. And as an additional information, for example, if you got matrix A, it is said that if matrix A can have a trivial solution, that means that the structure is stable. As you can see here, if you manage to get the whole matrix A have a trivial solution, then that means that it is stable. So if you cannot get the matrix A to be stable, then you need to ground one of these or both of these. So for example, in this special case, we need to add another more from node B to C. So we need to add another row. That means that the matrix A will finally be a square matrix. So well, I'm sure you have seen this kind of formula as Shaarmini presented you. So Ku equals to F, where U is the displacement vector and F is external force. Now the question arises that what is K? So K is equals to A transpose times C and times A. And we know A must be a square matrix as it have a row echelon form. But we don't know the condition of C matrix. Well, C matrix is naturally the bar stiffness of the structure. Well, as you can see here, AT and A must be a square matrix. Then the fact is C must be a square matrix also to provide answer to K. So I think that is all. Thank you.